Hi, and welcome to our next level 2 probability video. In this video, we're talking probability trees. Let's get straight into examples. Example 1, a pack of 52 cards is shuffled and the card is drawn at random. This card is not replaced into the pack shuffled again, and a second card is drawn from the pack. So we're going to draw a probability tree that represents this scenario. The first card could either be a heart or not a heart. If you know much about cards, there are 13 hearts out of 52, and there are 39 cards that are not hearts out of 52. Right, now if the first card was a heart, the second card could be a heart or not a heart. Because the first card was a heart, there's only going to be 12 hearts left for the second card out of 51. And if the first card was a heart, then we still have 39 out of 51 cards for the second card that could be not a heart. Right, if the first card was not a heart, the second card could be a heart or not a heart. If the first card was not a heart, there's now only going to be 38 cards that are not hearts out of 51. And there's still going to be 13 hearts that we could pick for our second card out of the 51. Right, that was a bit of a tongue twister, but we got there. We've finished the tree diagram and it looks like this. So let's solve some problems. Problem A, what's the probability both cards are hearts? So here's our tree diagram and we want both cards are hearts. So we want these two branches on the tree. Now when we have two branches, we're going to multiply the probabilities to work out the probability both of them occur. So the probability of a heart, 13 over 52, times the probability of a second heart, 12 over 51, gives us 156 over 2,652. So we can answer this question by saying the probability both cards are hearts are either 156 over 2652. We may choose to simplify that down to 1 chance in 17. We may go top number divide bottom and turn it into a decimal, or we could multiply the decimal by 100 to make it a percentage. All of these are acceptable forms of probability. Right, part B, what's the probability exactly one of the cards is a heart? So here's our tree diagram once more. And we've got two scenarios. The first scenario is we could have heart or not a heart. And that means we're going to multiply those two probabilities to get 507 chances out of 2,652. But there's another scenario that could happen, and that's to not get a heart first and get a heart second card. And we're going to multiply those probabilities to get 507 chances out of 2,652. Now we want one or the other scenario to happen. So when we go and solve this problem, we have to add the two numbers together, add the two fractions to get the total probability of one or the other happening. And that gives us 1,014 chances out of 2,652, or we could simplify it down to 13 over 34. Right, part C, what's the probability at least one card is a heart? Here's our tree diagram, and we want at least one card to be a heart. So here's one scenario. We could get heart and a heart. Even though there's two hearts, at least one of them's a heart. So we multiply those probabilities to get 156 out of 2,652. We could have this scenario, getting a heart first and not a heart second, and multiply those to get 507 out of 2,652. Or another possibility could be getting not a heart first and a heart second to get 507 chances out of 2,652. So there are three possibilities. We can't have the fourth one, which is not a heart and not a heart, because at least one of them has to be a heart. So to solve this problem now, we just add up all these fractions and get 1170 over 2,652. Or simplify it down to 15 chances out of 34. Great. Thanks for watching.